All right, this is Math Chapter 8. We're looking at Chapter 1, Lesson 3, how to multiply and divide monomials today. All right, a couple quick things as we kind of start this up. The key concepts from our lesson was that to multiply powers same base, we simply add their exponents. So if the numbers have the same base, a 2 and a 2, we take the exponents above and we simply add them. 4 plus 3 becomes 7, and we can rewrite it that way. If it happens to be variables in algebra and it's the same base, a and an a, then I add the variables above that, m plus n, to see what that's going to be. Okay? And that's what we're working on today for product of powers. When I multiply, I'm going to add. So when I multiply products or exponents, I'm going to add. When I have quotients or dividing powers with the same base, now I'm going to subtract. When I divide, I subtract. So if I have 3 to the 7th divided by 3 to the 3rd, because these are the same base, I simply do 7 minus 3, or 7 minus 3, which is 4. In algebra, same thing, same base, becomes m minus n, as long as a doesn't equal 0, because then it wouldn't quite work out. So those are our two rules today. Okay, so if it says, if we have the same base and we're multiplying, then we add the powers. The same base and we're dividing, then we subtract the powers. Let's take a look at some practice problems from your book. This is from page 27 in your book today. All right, so first of all, we look at number 1 and we see that we have the same base, -6, -6. So that's my base, no matter what. And because it's the same base and we're multiplying, we're going to add the exponent values. So 2 plus 5 is 7. That's what 2 plus 5 is. When I look at number 2, they start throwing in both numbers and variables right away. That's not a problem. So let's play with the numbers first. I have a -4 and I have a +6. -4 times a +6 is a -24. No problem there. I can move things around with our different properties. Now a is my base here, and I have a to the 5th power times a to the 5th power. So I have to add the exponents. 5 plus 5 is 10, so I end up with a to the 10th power. So my answer is simply -24 a to the 10th power for number 2. On number 14, we're going to be dividing. Now the rule was the bases are the same, so I'm going to keep my base there, and now I subtract 15 minus 13. I subtract the powers because I'm dividing, and 15 minus 13 is 2. So this becomes 8 to the 2nd power. I could solve this one much like up there. I could say that it's also 64 because 8 squared is 64. Over here, I just didn't want to do -6 to the 7th power. Sorry. You could do it on your own if you want with the calculator. Enjoy. All right, number 5. Moving down a little bit. We have 16t to the 4th and over 8t. I'm going to break it in two kind of parts here. I'm going to look at the whole numbers. 16 divided by 8 happens to be 2. On the t side, that's my base t, I have 4 minus, because I'm subtracting, this is t to the 1st power. 4 minus 1 is 3, and so I have t cubed as my solution. I keep my whole number 2 there because 16 divided by 8, no problem, and then 4 minus 1 is 3 for t right there. The same concept can be applied over here on number 7. Now, I have 3 to the 4th over 3. And this is actually really 3 to the 1st power if I want to be technical with it, right? So 4 minus 1 is 3. So for my base, I actually have 3 to the 3rd power. And for my variable, I have x, and this becomes 4 minus 2, which is 2. I could multiply this out and get this a little further on. 3 times 3 is 9. Times 3 is 27, so I could say it's 27x squared, and that would be an acceptable answer as well. Looking at number 9 down below, we notice here they all have the same bases, 6 to the 3rd, 6 to the 6th, 6 to the 4th, and down here 6 squared, 6 to the 3rd, 6 to the 3rd. So I could begin by rewriting this as 6 over 6, and I can add my exponents first. 3 plus 6 is 9. 9 plus 4 is going to be 13. Down below, 2 plus 3 is 5. 5 plus 3 is 8. But I'm not done yet because now I need to subtract because we're doing division now. I'll have the same base. 13 minus 8 is 5, and so my answer would be 6 to the 5th power. Or again, I could solve that out and keep going with it to find out what that's going to be. Alright, let's look on the back side, because I have some great problems here on numbers 14 through 19 that I'll take a look at with you. On these problems here, they are already giving you the answer there. It says to find the missing exponent, which means there's something missing in that dot space there that we have to determine. So I have to ask myself, I have a base of 6 and a 6 and a 6. No problem. But my exponential value at the end happens to be 5. So what they're asking me, because of how the property works here, is what number plus 3 is going to give me 5. That's all they're asking you to do, because they already gave you the 3 there and the 5 there. So what number plus 3 gives you 5? The answer would be 2. And that's my missing number for number 14. When we look at number 15, they make it a little more complicated, because here's my whole number, 3 and a 4, and 3 times 4 is 12. Okay, no problem. That's good to go. Got it. But I still have the x's. I still have x to some power times x to the 3rd power equals x to the 12th power. And because of my rules, these have to add up. Something plus 3 has to equal 12. Well, I could do 12 minus 3, go the other way. So what's 12 minus 3? 9. So my missing value is 9. That's what we're missing over here in that one right there. On number 18 down below, same kind of idea, right? We have 5 to the 9th, right, times 5, or really divided by 5 to I don't know, equals 5 to the 4th. Now when we're doing division, this becomes 9 minus something equals 4, right? That's the part we're really worried about. The bases are all fine. So we're looking at 9 minus what number gives me 4? Well, again, I can solve this by moving things around or just knowing 9 minus 5 gives me 4. So that is the missing value for number 18. Number 19, the last one here for our problems today, which is another great one. I can see the whole numbers. I have 2 times 3 is 6. So I can ignore the 2 and the 3 and the 6. No problem. But now I have x times x squared over x to the 6 equals x cubed. So what we're saying in this case is x to some value times x to the squared divided by x to the 6 equals x to the 3rd. So think of it this way. When I multiply, I'm going to do that plus 2, and then I subtract 6, because I'm dividing here, is going to equal 3. That's the problem I'm trying to figure out. What number plus 2 minus 6 equals 3? So I could work backwards. I could add 6 to this side. So what is 6 plus 3? 9. I could subtract 2 to both sides. And 9 minus 2 is 7. So box, my missing value, is going to be 7. Kind of a fun problem, because you have to think backwards a little bit for how are you going to get back to there. Alright? Hopefully it helps you out a little bit, and you can do the rest of the problems and the extra practice. And again, if you have more questions, just check in with your teacher. Have a great day.